Hello students, today we discuss IB Physics HL Paper2 November 2018, and we will use calculator. So you should use calculator in this paper. My name is Nariman Melim. I am located in Baku. Here you can see my mobile and email. The main sources to prepare for exam is textbook from Oxford 2012. I recommend you to have Mathematics HL guide, but what is more important, you should have data booklet, Mathematics HL, and you need to learn how to use formulas for this booklet, because this booklet will be available for you at the exam. Don't pay attention to further Mathematics HL parts, only to Mathematics HL. Let's start. So this is the cover page. This is the cover page. So, okay, right. So exam is for 2 hours. And you should use calculator and data booklet, graphic display calculator, and data booklet will be a clean copy of Mathematics HL is required for this paper. Let's start. Section A, question 1. Consider geometric sequence with first term of 4 and fourth term of minus. A. Find the common ratio of this sequence. Question 1. In data booklet we find section 1.1 nth term of geometric sequence given by this formula. We know that u1 equals 4 and u4 equals so much. To find common ratio, which is r, we divide u4 by u1 and we get r cubed. So r cubed equals this ratio. Now we use calculator to solve it. So we put calculator on, then you can press clear, for example. To find r, I should find cubic root of this expression. So I do the following. I go to math, and here I see there is cubic root 4, line 4. So I choose line 4. Now I use brackets because in case, I don't know, in case. So here use this minus, not subtract, minus 2.916 divided by 4, bracket closed, divided by 4. I didn't say 4. But I think I made a mistake here. I should insert one point. So I go to this position. I press second deal, which gives me insert, and I put here point. To return to the end of the expression, I press second to the right. But I should come closer by one step, so I close the bracket. Finished. So now I press enter, and this is my result, minus 0.9. So I copy this result here. This is the result. So this is done. Find the sum to infinity of this sequence. Section 1.1, the sum of an infinite geometric sequence is given by the formula. So 4 divided by, don't forget brackets, 1 minus 0.1. This gives me, so 3 significant figures. So I keep 2, 1, I keep 1, and the last one I round. I round up because 5 is more than 4. So I get to 14, so let's check 1, 2, 3 significant figures. So I give answer to 3 significant figures. This is a standard. Question 2. The function satisfies these values, and its second derivative is given by this formula. Find f. So first we'll try to find the function itself. Because it is some derivative, we should integrate it 2 times. So we rewrite square root of x as x to the half, x plus 1 minus 2, and now we use standard rule for integration. 15 is coefficient, exponent we add 1 and we divide by this value, so 1 over 2 plus 1 and divided by 1 over 2 plus 1. Then plus, again, exponent we add 1 and we add this number here. And we don't forget that it is indefinite integral, so we need constant a. Second integration, we do the same way, and here we have 1 over integral, and we use section 6.2 derivative of logarithm x. So derivative is opposite function to integral. We use substitution of variable by t equals x over t equals x over 2. X plus 1, that's a mistake here. So plus 1, oops, plus 1, and then we integrate and we get logarithm x plus 1 absolute value. So we substitute, this is the expression for our function, and here we get one more. When we integrate, in the end we add one more constant b, and a integrated gives us ax. So we have the value. Now we use this point, so f at 0 equals minus 4, f at 1 equals 0. As a result, we have this two expressions. Out of second expression, we find that b equals minus 4 because logarithm of 1 is 0. So we know b, we can find a. So we'll find a. So this question is finished. And we know a and b. We substitute a and b into our expression, and this is the answer. So question is done. We found the function. Question 3. Question 3. Sorry, we should return. Interesting, something interesting happened. Aha, question 3. I don't know what was happening. Right. Okay. So it is known that 56% of batteries have a life of less than 60 hours, 95 have life less than 17 hours. It can be assumed that the battery life is modeled by normal distribution. So we have normal distribution. Find the value of mu and the value of sigma. So we have normal distribution, and we have values for normal distribution, but we cannot use it because we don't know the parameters. It is mean value and standard deviation. For this reason, we use standardized normal distribution. So there is some value z1, and for this z1 the left part has probability 56%. This value z2 and left part has probability 94. So let us find this value z1 and z2 using our calculator. So first we know that probability less than 16 equals 56. So we press second vars. We need line 3 inverse normal because we should find z. So array is, attention, not 56% by 0.56, taking into account the array is probability. The total probability is 1 and this probability is 0.56. Then we use standards, so we can we use mu equals 0, sigma equals 1, it is standard, and we are looking for z value, z1, let's say. We press enter several times and this is the value, and we copy this value with, I copied with 5 significant figures, actually 4 is enough. So finished with z1. Now we should do the same for z2. So z1 will be 16 minus mu over sigma. This is the formula of conversion from x to z or from z to x, doesn't matter. So x is 16 hours, z1 is 0.15, about 0.15. Now we use second information. When x less than 17, here mistake, as usual. Let me correct it. When we have here less than 17, again, so we should find, we press second vars, we use inverse normal line 3, this time it is 94, right? This we just press enter, 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 and enter, and we find, oops, we did something wrong. What was wrong? So we can go up, we can press enter, and we can correct my mistake. Mistake is I forgot point, so I should insert point here. So second deal, I insert point, I press enter again, and now I get something strange. Because I should have 94, not 9. What I have here, very strange. Again enter. I go. I should have 94, so I should do 6. I delete 6. I press enter, and I have value 155. This is second z, 155 and 4, second z. Right. Now we scroll, so we have two equations. These two equations are for mu and sigma. I rewrite these two equations. Here we have these two equations. I subtract R2 from R1 to eliminate mu, and I get sigma. Sigma will be 1 over this expression. And then I use the first one to find mu. So this question is done. Question B. Find the probability that the randomly selected inflow battery will have a life of at least 15 hours. Probability of at least 15 hours equals 1 minus probability less than 15 hours. Now we should have normal CDF. CDF means cumulative. Cumulative probability. So second, so TI, so here I have steps. So you can see I have written steps. Here I see mistake. 99 should be 99. Right. So this is the lowest possible value. Right. So second var normal CDF, it is second line, so 2. Lower is yes, I agree. Upper we put, so upper we put 15. Mu we have 15.9, so it is normal distribution, not standardized. And sigma we have 0.7. Okay, paste. But I calculated this part, so I should 1 minus answer, so 1 minus answer we can insert by pressing second and this minus answer. This is what I need, and I round it to 3 significant figures. I get 897. I don't know why it is different from Max Scheme. Max Scheme says 895. I have no idea. Question 4. Question 4. Find the value of the constant term in the expansion of x to the 4th and this expression. Constant term has 0 power of x. So if it is x minus 4, c on n is 5 over r, x5 minus r, 3r, x minus 2r. Because we have 3 here and x minus 2. So then we equate the exponents. Exponents together will give us 0, because on the we have x to the 0. So we get r equals 3. So the coefficient will be C53 times 3 to the 3. So this expression. So let's assume that you hate this value. So how to use calculator and not to use factorials, etc. So I want to calculate, to multiply C35. So I put, so let's clear everything. Clear, right. I put here 5. Then I press math. I go to, you see here probability, so I can go, the easiest way is to move to the left. So now I'm at probability, and I see the line for NCR. It is third line. And if I press 3, I have it. It is 10. Now I should multiply answer. I just multiply and it writes itself answer times 3 raised to power of 3. and I get 270. So this is the answer. Finished with this question. Let's go further. So this answer I used from mark scheme. So you should find derivative from the first principle. Again, something is happening. I don't know what's happening. Right, so we are at question 5. Question 5. I use a solution from mark scheme. Why not? So, differentiate from the first principle the function fx 3x cubed. Right. So, from the first principle means that you should have this expression. So we should open this cube. So we opened it using binomial theorem. 1, 3, 3, 1 are coefficients. Then we simplify. Then we divide by h and we get this expression. Now we should find limit when h is negligibly small. So this becomes 0, 0, and we're getting 9x squared minus 1. Let's check it. So we know how to differentiate 9x squared minus 1. Yes, we got it right. Question 6. Question 6. So we have some polynomial and a. Given that x minus 5 is a factor of p, find the relation between a, b, and c. So there is theorem that the remainder of dividing by x minus 5 will be p at 5. Because it is factor, remainder should be 0. So we find remainder and make it 0. As a result, we have this expression. B. Given that x minus 5 squared is a factor, write down the value of first derivative at 5. So if it is a factor, we can express our function in this form, and when we differentiate by parts, we will get this expression. At x equals 5, this expression becomes 5. So answer is 0. C. Given that is a factor of p and a equals, find the values b and c. So, because x minus 5 squared is a factor of p, we can find a value of b I think they made mistake here. Right. Okay, so we found that x minus p is a factor of p, so we still have this value, right? So we have the same condition, but now we know that a equals 2, so we can find b. So p, again we use the value of derivative at 5 equals 0. We know a, and we can find b. Then we use our first expression from a. We know a and b, we can find c. This question is done. So we have here both a is situated 10 kilometers from boat B, and each boat has marine radio transmitter on board. The range of the transmitter on board 7 kilometers, the range of transmitter of B 5 kilometers. The region in which both transmitter can be detected is represented by a shaded region. Find the area of this region. So I have copied this here, and I have drawn radiuses and this chord CD. So to find area, for example, this shaded area, I should find area of sector minus area of triangle, or I can find this sector minus ACD triangle. How can I find angle? So I need angle theta 1. To find angle theta 1, I use cosine rule. So this is AB is 10, this is 7, this is 3. So I use cosine rule to find theta 1. So this is, and angle will be cosine minus 1. So I have written everything here. Now I know angle theta 1. This angle will be 2 times more. I use arc area from section 3.1 as half theta r squared. Triangle area as half AB sine AB. Angle between A and B will be r squared, and so I actually have the following expression for right. So this shaded area, I should have 2 theta 49 minus half 49 sine 2 theta, so this expression. For left shaded area, I have the same expression, but 25 radius is, why 25? Radius is 3, so 9, so it should be 9, so here 9. Radius 9, squared, radius squared 9. 2 theta 2 minus sine theta 2, so I calculate one expression, another expression, add, and I get this value. So question is done. Question 8. So consider the function. The following graph shows the curve of squares of this function. It has asymptotes x equals p, y equals p, and meets the x-axis and y at y. So on the following axis, sketch the 2 possible graphs of y equals fx. So this is f, this is fx. What will stay the same, what will be different? If fx equals 0 at this point, fx squared equals 0 at this point, fx also will be 0 at this point. If we have asymptotes, y asymptote equals q, then this function will has asymptote at square root of q, or minus square root of q. If this function has asymptote x equals p, this asymptote also will have function asymptote x equals p. So we have actually two solutions. Fx equals plus square root of y, where I mean y is this function, or minus. So I lost one asymptote. Let me return it here. So f equals plus square root of y. As I told, y equals one asymptote is y equals square root of q, x equals p asymptote stays, and point A is the same. Now function minus y. So now we have asymptote, negative asymptote, and we can construct this actually using function minus with minus. So positive becomes negative, negative becomes positive, and positive becomes negative. So we get this function. Given that p equals so much, q equals so much, and a has coordinates, determine the possible sets of values for a, b, and c. So at minus half, f equals 0, and we get a equals 2. We have two asymptotes, x equals 4 over 3, and this asymptote comes from the fact that bx plus c equals 0. So bx plus c equals 0 means that x equals minus c over b, and ratio of c here minus. So c and b has opposite sign, and ratio is 4 over 3. Y asymptote is a over b, and it is plus minus 2 over 3. So from this we can conclude that so a is equal 2, so b equals either plus 3 or minus 3. Then c equals either minus or plus 4. So we have two combinations, and we write these two combinations. So let's summarize. So two asymptotes. X asymptotes comes from the bottom part of the ratio. Bx plus c equals 0. Y asymptote comes from the fact that when x we can divide by x, we get a plus 1 over x, b plus c over x, or we can use the fact that limit is equal to limit of derivative. So derivative of top part is a, derivative of bottom part is b, so asymptote is a over b. When x approach infinity, y approach a over b. And we know that this value is plus minus 2/3. I think it is clear. Section B. For section B we need to split our screen because solution will be given separately. Let's find the solution. Here we are, question 9. The function fx is defined by this value. Okay, find f derivative. So to find derivative we use quotient rule plus derivative of logarithm. section 6.2. As a result, we get this expression. Question done. Find. Okay, next. Hence or otherwise find the coordinates of the point of inflection on the graph y equals fx. So first I thought it is a mistake, but now I know that it is not. Check for point of inflection. Either we should find extremes for f first derivative, or we should find second derivative equals 0. F has turning points method. So we use our calculator. Now it's flipping. Make it alive, right, clear. Right, so y equals. And we insert our function, not our function, but derivatives that we got. So it will be 2 in the bracket x minus 3 minus x bracket 2 logarithm x plus 1 bracket closed, divided, bracket opened, x bracket open, x minus 3 bracket closed. Here we can use either this button squared or raise to second. Then we go to the right and we close the bracket. Now Windows. Press Windows. So we know that x is from 0 down to 3. Now we can draw. Oops, I did something wrong with our function. Let's see what was wrong. Quit y. Okay, so 2x minus x. Wow, what I have here? X minus 6. Instead of minus, I have here times. Minus 2 logarithm insert a second div. I should insert x and close bracket, insert, again insert and close bracket. Here I need plus 1. Plus 1. 2 logarithm. So I should return. So you should be very attentive, because calculator is slow, so you should watch what's happening. So we should not put insert every time. Once is enough. Right, okay. Let us watch. So let's go to the beginning. So second to the left. We're at the beginning. So we see bracket 2x minus 3, correct? Minus x times bracket 2 logarithm x plus 1 bracket closed. Should be closed 2 times. Let's close it 2 times. Right. Divided by bracket x minus 3 squared, and I don't see x times. I should insert x here. Ready. Let's see. Right, finished. Now we should find maximum. So to find maximum we use the following combination. Second trace, so we need maximum, it is line 4, and left bound is, let's say, 0, and right button is it is less than 2, so it is 2. Guess, it doesn't care what is guess, and here we have the answer. So the maximum is found at x equals 0.899. But they ask us the point of inflection of our function, not derivative. So we should evaluate our function. How we do it? We write y equals, type our function, then draw. After we draw second trace, choose one value, type 0.899, enter, and you get the value of evaluated value at this point. So this is point of inflection is point with these coordinates. Question 9. Okay, right, so we found, sketch the graph. Okay, let's put it aside. Sketch the graph of y equals fx showing clearly any axis intercept giving the equation of any asymptotes. So let's look to our function. This is our function. So x equals 3 is one asymptote. Another asymptote is x equals 3. Another asymptote is x equals 0, because x cannot be 0. So when x equals 0, f becomes infinite. So y-intercept is when the function equals 0. It equals 0, so it happens at this value. How to calculate this value? Clear? Right. If you want the system to return, just press second and mode, which means quit. Second mode for any position you can clear. So we need square root of 1 over e. So square root is second x squared. So now I need not this function. I need, so alpha f1, I need fraction form. Now it's easy. Now go down, then I press second and divide it, which give me letter E. Then I move out, just in case, out, and I press enter. I get the value 0607. Finished. So asymptotes we found, y-intercept we found, so this is our function f. So we found y-intercept, we found asymptote at x equals 3 and asymptote at x equals, so this is our function. Sketch function f minus 1. So inverse function will be reflection over y equals x. So I make reflection over y equals x, and this is done. Hence, or otherwise, solve the inequality fx more than f minus 1. So we need to find, actually it is between 0 and, so when f is more than f minus 1, between 0 and this point. This point is intersection of our function with y equals x. So let's find this intersection. So D, we are going to do D. So we should solve fx equals x. So first we press y1, we press here clear, and we insert our function. It is, where is our function? It is 2 bracket 2 logarithm x plus 1. Look to the screen, because otherwise you will make a lot of mistake as I did if you don't watch the screen, because calculator is a bit slow. So oops, you see I made mistake. Here should be minus, insert minus 3. Let's see. No, delete it. Okay, so minus 3 bracket closed. Right, let's check. So 2 logarithm x plus 1. I didn't close logarithm x give bracket, and I should close this bracket. And delete this. Okay, 2 logarithm x plus 1. So logarithm gives bracket, so you should close this bracket. Right. And let's check the rest part, x minus 3. This is one function. Another function is x. So what we're going to do, we're going to draw them and find intersection. So and it should be from 0 to 3. Yes, from 0 to 3. Let's draw. So you wait. Here you see that the calculator is working. So this line is running. It means that calculator is working. So you should wait. Now second line. Right. Then we find intersection. Second trace intersection. So second trace intersection is number 5. So guess first curve. Here we press enter, enter, and enter. Thinking. And this is the answer, 0, 3, 7, 2. Right, so this condition is true from 0 to 0, 3, 7, 2. Right, very good. Question 10. Mila finds that she receives approximately 70 emails per working day. She decides to model the number of emails received per working day using random variables x. X follows Poisson distribution with mean 70. Using the distribution model, find x less than 60. Okay. So this is district random. So next after 60 will be 59. So Poisson, we need Poisson for x less or equal to 59. Let's do it. So second var Poisson CDF, it is, so we work here, Poisson CDF, Poisson CDF, Poisson CDF, we press enter, oops, so let's put second and quit. Right, and clear. Right, let's repeat. Second was Poisson CDF, enter. So lambda is 70, enter. X value is 59, enter. Oops, mistake, it should be 59. Insert 50. Now it's correct. Answer is So we copy these three significant figures, 0.102. So this is the answer. Standard deviation of x. Square root of standard deviation equals mean. It is that standard deviation equals square root of 70 equals. So this is exact answer, this is approximated answer. Let's look what we have. In order to test her model, we will record the number of emails she receives per working day over a period of 6 months. The results are shown in the following table. From the table, calculate the estimate of mean number of emails received per working day. So two methods. Long method is to use section 5.5, expected value of discrete random variable, so for mean we have sum of value times probability. Probability is number of events divided by total. So actually we need this expression, and you can do it. But you can also use another method, use calculator, and this will help you actually to answer second question, standard deviation. Let's see how we do it. So to find standard deviation, so we know that variance equals this function, so we can calculate, or we can use calculator. I recommend you to use calculator. So how we use calculator? Right, okay, let's see. So first we should make lists. So start, edit, insert data. Start, where is the start? Start, edit. So we should insert x and frequency. So here we will use midpoint. Midpoint will be 44.5. So 44.5. Yes. 54.5. Yes. 64.5. 74.5. 84.5. 94.5. Oops, I did something wrong. 74.5. Yes, enter. 84.5. No. 0.5. Enter. 94.5. Enter. 104.5. Enter. And 114.5. Enter. Now we move to the right and we put frequency 2, enter, 15 15, enter. 40, enter. 53, enter. 0. Oops, 53 didn't work, so we move up. 53, enter. 0, enter. 1, 3, 6. 1, 3, 6. So we made list. Now we go to start. Where is the start? Start. Now we should calculate. And we calculate first variance statistics line. So list L1 is written, that's no problem, but L2 we should choose ourselves. L2, you see it has written L2, so second 2. Enter, calculate, and this is the answer. So what we have? We have I don't know why a bit different values. Probably I made mistakes. So mean values should be 71.1 and 72.9. So let's return to our list. So start, edit, here 15. Mistake. 15. Enter. Now let's do the same. Start, calculate, here it's ready. L1, L2. Now we have correct answer. So mean value 71.1 and standard deviation 13.9. Finished with this exercise. Very good. Give one piece of evidence that suggests Wheelow's Poisson distribution model is not good enough. So variance is so much, and we calculate it is not close to the mean. They should be equal. So D. Suppose that probability of Archie receiving more than 10 emails in total on any one day is so much. Find the value of lambda. So we have Poisson distribution. Lambda we know, more than 10, and probability is 0.99. How we solve this? So this is D. So 0.99 is more than 10. It means that less than 10 will be 0.01. So we use this value 0.01 for less than 10. Okay, so let's start. So first of all, here we get rid of these two functions, and now I will show something that I write clear. Oh no, clear. Okay, good. Right. Okay, my inventions. So first we write y equals, then we go to second var. Here we find Poisson CDF. And here we put x. Value of x is 10, less than 10. And we have function. Another function is 0, 0, 1. Now, in Windows, to save time, we put x minimum 0, x maximum 10, probability we know that it is between 0 and, let's say, 0, 1. Now let's draw. So it's working. We wait for just a very long time. So it takes too long time. We can't wait so long. So you should have two graphs, and then you press second, trace, and intersection. You can enter 3 times, but there is only one intersection, and you will get 20.1. Question E. Now suppose that Archie received exactly 20 emails in total in a consecutive 2 days period. Show that the probability that she received exactly 10 of them on the first day is independent of lambda. So this is conditional probability. Probability that A on the first day and 10 on the second day, at the conditions that she received 20 on 2 consecutive days. So probability of 10 at first day and 10 at second day will be product, and probability of 20 will have mean 2 times greater. As a result, you have this expression. I just copied it from Mark scheme, and then you simplify. Right, I did something wrong with our function. I don't know what. Let's see what is wrong. Poisson CDF strange. Okay, I don't see Poisson at all. Sorry, but it worked, so I checked it. Right, so now the last question is the following one. So we have a diagram, and P, Q, R are in this relation. So we have theta P is angle APO, theta Q is APO, APO, AQO, and ARO. Right. Consider that angle TP equals TQ plus and QR equals 1. Show that this expression. Let's see. So first of all, tangent of theta P equals 1 divided by P. Tangent theta P. The same for other angles. Then we use compound angle identity for theta P. So theta P, we should okay, so because we know this relation between angles, theta P equals TQ plus TR, we can write it here. Then we use identity. Then we replace tangent with 1 over. When we use relation between RQ and 1, so we replace R by Q plus 1. Then we rearrange and we do this, right? Okay. By sketching the graph of P of function Q, determine the range of values for P which there are possible for Q. So actually we can draw this function. Right, so clear, function Q X, oops, what is going on? Nothing. Bracket X squared, I didn't get X, oops, bracket X squared plus X minus 1 plus X minus 1 divided by bracket 2x plus 1, bracket closed. So P should be positive and function should be positive, and let's put here 100 for example. Not 100, 10 because the value is less than 10, and y the same, 0, 10. Let's draw. Okay, so this is the graph. So Q can be because it is by 1 from because QR equals 1, OQ cannot be more than 9, so it is less than 9, and P should be more than 0. So P is from 0 to the value corresponding to Q equals 9. So let's find the value when x equals 9. It is 460. So we found the maximum value and the minimum is 0. So paper is over, but I want to return to the question that I couldn't do, so let's repeat this question. I don't know what is the reason. This was about Poisson. D. D. Let's D. Question D. Inverse Poisson. So y will make, so x will, suppose that probability of receiving 10 emails in total of any number day is 0, 9. Okay, let's x may from 0 to 100. It is value for x, and probability, let's make maximum 1. Right, so we come here, we clear our function. Now we do the, okay, so y equals second var Poisson cumulative this is x, this is 10, and here we put 0, 0, 1. Aha, now it draws. Interesting. Before it didn't. Okay, this is question. Which question? question. D. So it's working. Should draw two lines. One line can be very small, 001. I think it's wrong. No, still working. Yeah, we should wait. We should wait. So Poisson here, it has drawn, and it is somewhere here, so about 20. So we should get the correct answer. So finally, what you do, you press second, trace, intersection, enter 3 times. It finished. Second, trace, intersection 5, first curve, second curve, guess, works, thinking. And answer is 20.1. It recalls everything what we did. So second answer. Do we have an answer? No. Okay, finished. Thank you very much. Paper is over.